better have it. Okay? Okay, cool. So now whenever you try to, for example, get a height, and this one's, please do this one's yourself, alright? We can have a look at this guy, however. For example, whenever you try to insert something, some specific node, in a binary search tree, you must follow its rule, correct? So first, suppose this one as your pseudocode, for example, okay? So in the very beginning, what you do is, you check if the root is equal to null, alright? If the root is equal to null, then the thing that you're trying to add will automatically be regarded as the root itself, correct? Okay, good. So if the root is null, then tree is empty, so make root the thing that you're trying to insert, okay? If not, then you make current, you take a copy from the root, and you understand why we need to take a copy, right? Because we're not doing recursion here, alright? So we take a copy from the root, while current, this guy, is not equal to null, then go, right? And train current is equal to current, and take another copy, okay? And what we need, now you understand better, so current's info, or you can also understand this one as value, okay? It's just this one is too general form, so we're not just considering integer types of data, so it depends on whatever type of data you're considering, okay? So current info is the same as the insert item, then error, cannot insert duplicate. Now, this part, do you remember from, for example, CP1, STLs? For example, set, ordered map. So duplicates were not allowed, correct? So that is actually the rule of any kind of binary search tree, right? So duplicates are not allowed by rule. You understand? So here the same thing has happened. If the current node's info is the same as the node that you're trying to insert, then you cannot insert it. Okay, you simply print, for example, some error message, and you do not let it happen. Okay, and otherwise, else if current info is greater than the item that you're trying to insert, then follow left link of the current info. Right? Why? Because current is greater than the thing you're trying to input. Right? So you're checking this one, and this is smaller, so where this one should go? To the left side. Okay? So that's why you instantiate the left link of the current node. Alright? Otherwise, you follow the right side of the current. Okay? And you try to find its location, the one you can find. So, and after that, in here, you will insert a new node in the binary tree if this one is finished. Okay? Now, if train current info is greater than insert item, make a new node, the left child of a train current. By train current, we mean the node you stopped at. Okay? The node you stopped at after this one. Alright? And after that one, now we need to check if train current's info, now the node you stopped, is greater than insert item, is greater than insert item. Then insert item must be the left child of this train current. Correct? Otherwise, it must be the right child of this. Do you understand? So basically, one more time, duplicates are not allowed. Okay? So if you see something the same, you just do not insert it and print some error message, return some specific information depending on what you asked for. Otherwise, you simply should go, okay, to the left or the right. You go to the left whenever the item that is smaller than the current node you're at. Okay? So you go to the left. You continue going your path until you reach the very node in which you stopped by, right? For example, left link, you came in here and you make sure that the left side is too small than the item that is being inserted, and the right side is too big. Now you understand that this one has to be inserted right in here, correct? Okay. And in that case, you will need some rebalancing as well, but we'll talk about rebalancing as well, so don't worry about it. Okay, now, the rest of the information, I would like you to have a look yourself. Okay, there is a lot of useful information. We'll have a look one more time at them. by making a makeup class, because we now must pay attention to something that is more important than this one. To treat traversals. Okay? Now, do you remember that in the very beginning, or last week, I've been talking about two types of methods that are usually used with dynamic programming. Not even starting from the last week, but at the time when we introduced recursion, I talked about it, right? So there is BFS and DFS, right? So now you will make sure that these ones will remind you something as DFS or BFS very much, and you will understand what they are specifically, okay? So the types of traversals that we will be having a look are in order, post order, and pre-order, okay? And pre-order can also be regarded as level order, okay? All right, in general, there are just three types, okay? Level order is not a separate one, so don't make any mistakes. Okay, for deletion, maybe we will not pay attention today, but it's very similar to the one we've been having a look with Destructor, and it's just this one also is going to be using some of the rebalancing trees. But what we will pay attention is the rebalancing trees, okay? Anyway, pay attention. So, suppose we have all these three types, okay? For in-order traversal, what we can understand this one is, we should first visit left subtree, okay? Then visit right subtree at the end. Okay, so very first left subtree, okay? And very last right subtree. Now you will understand why very last. So in here, pre-order traversal. Visit left subtree second. Okay, not first, second. Alright? And your purpose goes in as the first. Okay, for example, you might have some kind of condition, for instance, right? It doesn't matter, it could be anything. For example, if you like to print something out, correct? You first print that thing and then go to the left. Alright? So in here, however, you first go to the left, okay? And then print and then go to the right. Do you understand? Okay, cool. In here, however, in a post order, you visit left subtree first, right subtree second, okay? And at the last, your purpose. If you want to print, you first go to the left, right, whenever left is finished, and then you would like to. You understand? Now let's pay attention to the codes. Okay. Suppose we have this example. We got a root pointing at 8 and some addresses. Okay, and these values. Now, in order traversal, we're trying to traverse through that tree, okay? And for that, we first check if PTR is null PTR or not. It's not. So if PTR is not equal to null PTR, we go inside. And we call out in order, go to that side. PTR left, okay? And then we will print out for our purpose. It depends on you. For example, if you'd like to save it in some data structure, this is where you do it. Okay? So, and after that, you go to the right side. Pay attention, these ones are the recursive calls, right? So in order, this one, the purpose is in the middle. Okay? Good. And for instance, let's examine this case, right? So we first have 8, root is pointing at 8, correct? So now we first go to the left side, okay? So bringing to the left side. Then we are at 3 now. Now we go to the right side again, okay? Left side again. So we're at 1 now. Now we go to the left side of 1, and that is null PTR. See this? In order, now this is null. And now this is null, and now we start printing out. We finally reach this point. And now we print what? We print what now? We print 1. You understand? Because after 1, we went to null PTR, correct? Now this is green. Green go to that location, correct? Do you understand? And that location is now null. And because of that null, we came back in here. PTR is invalid, correct? So we came in here because of that. And because this is void, it means for the previous function, which is we were at 1, right? Node 1, correct? So we came to this line after semicolon. You understand? Because inside in order PTR left, it was no PTR. You see this? It was no PTR. So that's why we first tried to make sure, is it null? Yeah, it is null. So it is null, right? So it didn't go inside. Then we came back, finished that function, and then we are now at here. Okay? First one. And according to that, we need to go to the next line. The next line is this guy, right? See out PTR data. Now, what data do you print first? So we're at 1. So we print 1. You understand? Now, if you have printed this one, you're at here, correct? Now, where should you go? To the right side of what? Of node 1. You understand? So, okay, the right side of node 1 is what? Okay, now you're going there, so it points at no PTR, so it comes back. And here, it comes back one more time. Why? Because 1 has already been printed out. So it has performed its job, correct? And here, after that, you simply come in here, correct? And finish that function, and now you're at 3, this location. Do you understand? Yeah. You're at 3, but this location. You come in here, you do what? You print the data, and you come in here, in order PTR right. Okay. You come to 5, you check left side of it, and then right side, and you do the same, and then you print 5. Do you understand? Now, where do you go? I'm not going to continue, but where do you go? What do you think? We do first one. Okay, suppose we came back to 5. We printed it out, correct? We printed it out. Then we should go to where? Right side of 5, correct? So the right side, we have no PTR, correct? You understand? Can you imagine? Question?
Maybe 3?
No, why 3? Look, this one has already been performed. Look, initially, after 8, you did what? You went to left, correct? You came in order PTR left, right? So you went to left one. Now there is a root, correct? Now I'm at 3. After 3, I went to 1 again. Now there is another root, correct? That is 3. And now I'm at 1. And after 1, I decided to go to the next one, and I have a look, it's no PTR. Okay, I understand because of that. It's no PTR. I check the condition. If PTR, that fails, right? So it failed. Now, according to stack, where should I be? I should come back to 1, correct? Now this is ended. I forget about it. Okay? Now I'm at 1, but I need to print 1. See how PTR data. I need to print 1. Okay, 1 is printed. Now I'm at next line, in order PTR right, correct? So from 1, I go to the right side of it. Okay? Now I see it's no PTR again. So according to stack, where was I at in the previous place? I was at 1. I come back at 1. But look, I don't have another C out after in order PTR right? So I do not print anything out. If I had something to print out, for example, another C out PTR data, for example, I would print 1 or 1. You understand? So that's why there is only 1 1. So it's coming back every time as if told to 3 or any other one, but it's just printing out the purpose at the very middle. So now I came back at 1, right? So 1 is finished, correct? Because all the inner side of if statement is finished. Now I come back to what? 3, correct? So 3 was here. Left 1 has performed its job. Now I should print the data. I'm at C out, correct? So I print 3. Then I go to the right side of 3, okay? Now at the right side of 3, I have 5, correct? Now I need to do what? I need to do left. In order PTR left, correct? I go to the left side, move PTR. Okay, I come back. And while coming back, I'm at line C out PTR data. So I print out 5. You understand? Now 5 is printed out, I go to the next one. Go to right. Right, no PTR, come back to 5. But do nothing. Now if statement finished, so I go to the one last operation, one previous function, which is again that 3. Okay, now 3 is completed both sides, left and right, correct? So now there's nothing left for this guy, so that's why it also finishes and comes back to 8. So 8 in here. Now for 8, what should I do? I'm at see out PTR data, so I print out 8. So left side is finished, 8 is printed, so I need to go to the right side of it. So 8 right. Correct? Now again I should start with the left. Right? And in the left side of 15, what do I have? So I have no PTR, right? So no PTR, I come back, print 15, I check the next one, write one, right? And write nothing, come back, and both nothing, so finish. You understand? So it comes back to 8, and 8 was the root, right? So before that there is nothing, so that's where you started, now that's where you end. You understand? Because that was the very first function, just like main. Do you know how, you guys know how main works, right? So it's just like main then. That was the very first call, and that is the very last one to complete. You understand? That is how in-order traversal works. So we, again, coming this way, we printed out this guy, we come back 3, 5, like this, 8, then 15. Okay? Like this. Alright? Do you understand? Any questions? Every time try to imagine what's going on. This is going to help your exam a lot. Trust me. By the way, one good news. So part 1, you will again have 20 questions as usual. You may use computer, but trust me, it's not going to be useful. Okay? Just you know, alright? What kind of benefits can it give? For example, if you're really smart and you finish, for example, part 1 really quickly, then you can start your part 2 as soon as possible. Alright? Cool. If you can think of any kind of advantage as far as using, for example, computer, you're good. For instance, from the other university, there are some couple of talented guys, and for some reasons they forgot how to calculate, binary to hexadecimal. It's very simple, right? For example, you know that this is power of 2, and etc., etc. So what he has done is he made a code which would compute, from vice versa, like by dividing. So a couple of conversions is done. Anyways, he's completed good job, not bad. So that was only possible, but I laughed a lot. But anyways, it was good. Okay, now let's pay attention to pre-order. Now the difference of pre-order with in-order. Now see outcomes before you actually go to that order. You understand? So for example, whenever we are at root, we should do with first one. We right away print 8. We print 8. Okay? Then we go to the left side. Okay, we come into the left side, we print 3 right away. Okay? This one. Cool. Then we go to 1, we print 1 right away. Now after 1, we should check 1. Left side and right side. Goes to OPTL, will come back, right? We come back. Then it's done the same way. 1 is finished. We come back to 3. What is that? We come back to 3, and then we go to right. Right is 5. And while coming into 5, PTR is valid, right? Because it's 5, right? And see out 5, and then 5's left and right. 5's left and right are both smooth PTRs. Okay. Now it's just you're skipping a lot faster because you already understand what's going on. Okay. And after that, you print out, for example, not 8. 8 has been already printed out, right? So you're at here, you go to the right side. While coming here, you print out 15, and that's it. You understand? Now, in the first order, however, what you should do, you should first go to left side. Okay, good. Left side 1. Left side, go to here. Now, no PTRs checked. You know that? You came back at 1. And now you're at right side, here, not right side. So you're back in here. Okay, good. Now, when right also received no PTR, right? When first of all the PTR right also completed its job, which for the very first time it happens in here, correct? Because first you check with its left, no PTR, comes back to 1, and then it's right, also no PTR, right? and right is post all the PTR right. That's also no PTR. Come back to 1. And after that, PTR data is printed out. So we print out 1 at that point. Okay? So first we print out 1. And then we go to, for example, we come back to 3. Okay? We go to, for example, 5. Alright? Now 5, no PTR. 5 is right, no PTR again. Now this is where we print 5. You understand? Now, does it remind you something? So what are we printing out first? 1 and 5. So this is level or postal, similar thing. Okay, for breadth first search, the main difference between breadth first search and this guy is that breadth first search starts from here as well. But you can also regard this one as breadth first search, so that's also fine. Okay. Anyways, now you print 5, and then you print 3, and you come back to 8. Okay. After 8, you should also go to right side. Correct. You go to right side. Now you're at 15. You check both sides. After right is also no picture. You come back at 15 and print 15. You understand? So you first printed out 1 and 5. If you have more data in here, you will of course print out those ones at that specific level as well. Okay. And then you complete that job, and at the very end, you print out. You understand? Does it make sense? So again, look. So post order. First, lowest level. Next, one previous level. Next, like this. Okay? So like ladder. Okay, level by level. Alright? So in here, let's come back, where's the P? Now, this guy, pre-order. First, it's also like this, right? 8, then 3, and 1. Okay? It's depth one. It's going depth one, right? 3, and 8, 3, 1. And then you have your 5, and then you have your 15. It's like this. Okay? Do you understand? Makes sense? Okay. And the previous one is?
In order?
Yeah, in order. You first come in here 1, 3, 5, okay? Like triangle. Every time. Okay? So like this. Now this is finished. So we start with 8, do this. If it had more children, for example, you will of course do triangle with those children first. And then you come back to 8. You understand? Are you sure? Okay. Traversals are good. We understood. Now there is a lot more information for you to read. Okay, I will upload all the data. And this is level traversal. This, for example, using trees as well. And this is very useful for your lead code. Okay, this is really frequently used. Okay, and as soon as we organize our makeup class, so we have to organize it this week because next week we have your exam. So the same goes for the okay. Why is it over there? That is the best day that you guys have the freest time.
Yeah.
Like I can organize all of you. Okay, anyway. So please have a look at this one. We'll decide about the makeup class. Maybe if you guys don't mind, okay, I will not make any attendance, but we might possibly have a makeup class from 5 or onwards. Okay. Okay. So I will not make you like come as a compulsory basis. Okay. But if you would like to have a lot of information which is useful for your exam, please come. All right. And we'll be going through these information one more time. And if you bring up as many questions as you can from the previous topics as well, I would be glad.
Okay.
The better the question you have, the more other students will also learn. Okay? So that will be open for all. So I cannot organize 2 extra makeup classes, 1 makeup class. Okay? Possibly after 5. Alright? Cool. Alright. So this one, please have a look. It's really useful. Alright? It's just now, instead of printing out we're using queen. You can do the same with stack as well. Okay, there are some problems which can easily be solved with using queen or stack. Okay? And you can also use vector. Alright? Now, there is also deletion. I will also upload that one. But for the last 20 minutes, we have to be talking about these guys. Whew. Now, do you understand why do we need self-balancing trees? These self-balancing trees are actually also BSTs, okay? It's not BTS, so don't confuse it at all, alright? So it's BST. And I decided to add this one more S at the very end so that we never get confused. Okay? Because that's a huge mistake. Okay. Now, we will be having a look at 3 types of BSTs, okay? And I've taken this data from mainly 2 sources, and I'll be sharing the links for those 2 sources. Okay, they are very student-friendly, okay? They are not using any kind of mathematics or whatsoever, so they are quite useful for you to imagine. And one is from Gigs for Gigs, of course, and the other one I've shown already from the previous lectures, tutorials point, okay? Anyway, so ABO is the first type of tree. Okay, this is also regarded as a self-balancing binary search tree, BST. Okay, also its leaf nodes must be at least n